Hey everyone, welcome back to my channel where I talk about all things tech and finance. And in this video, I'm going to be going over regular expressions, otherwise known as regex. Regex is incredibly useful in many different industries, but in particular, it is really useful just for a data science knowledge foundation. You use regex in order to find patterns, and then once you found those patterns, you want to replace those patterns with whatever you might want to replace them with. And for all the window users out there who use Control F on a daily basis, whether to be searching for a specific keyword item, you can think of regex as the Control F function, but on steroids, because you can look for specific patterns, not necessarily like a consecutive string of text, but patterns of a text, and then you can go ahead and highlight the entire document or data frame, and then you can replace that with a specific text or even other regex functions. A regex function looks something like this: hello in R. In its most simplest form, you are passing a simple line of text to a regex function to find any patterns that exist in the text. It's as easy as searching for a keyword. However, what if you want to look up a date? And not just any old date, but a date that follows a specific pattern, such as month, day, year. Well, the regex function will look something like this. And this function might look scary at first, but later on we'll go more into depth on what this actually means. Let's go over the most common special characters in regex to understand the structure of a regex function. The backslash character gives meaning to the following character. For example, \n indicates a new line, \w indicates a word, \d represents a digit character, and \t indicates a tab character. These special characters are known as special control characters, and I attached the link in the description if you want to know more about the special control characters, but the \n, d, w, and t characters are by far the most commonly used. There are, however, many more characters that you could be aware of, but are not as commonly used. Let's talk about anchors. The caret symbol is an anchor for the start of a string, so C matches any string that starts with a C. The caret symbol can also act as a negation term, and if it is used in a bracket, then you know that the negation will commence. The other anchor term is known as the $sign. This is to match any character that ends at the end of a string. Let's go to the opening and closing characters. The curly brackets represent a range qualifier. The parameters of the curly brackets are minimum and maximum values. So a curly bracket 2, 3 end curly bracket matches any string that has consecutive character A's that must have either 2 or 3 consecutive letter A's. The square brackets define matches any character that is defined in a range. Note that this is only matching a single character at the beginning of the string. So bracket A dash Z matches any character in the alphabet, whereas A dash C matches A, B, or C. Also, if we use a caret symbol here, then we know that we can negate the values, so the meaning of caret 0-9 represents any character that matches non-digit characters. The parentheses are used for grouping characters. This will become useful in RStudio when we want to group terms together for easy references. There are several other miscellaneous terms, but the more commonly used ones are the following. The plus symbol matches one or more qualifier. The question mark matches 0 or 1 qualifier. And you can think of this as a Boolean value. So if it exists, you should include that specific character. If not, then who cares? You can just move on. The pipe character is an OR operator, and you can think of this as a mutually exclusive term. And that pretty much just covers all the real basic regex expressions, and you can use these in tangent with each other in order to find very customized patterns. And this is incredibly useful when we are working with large amounts of data, especially if we want to clean our data sets to get it in a very specific format, and using the typical Control F search and replacing very specific values like converting all hellos to worlds, for instance, will become very tedious, and using this particular pattern recognition will automate the process so much more effectively and efficiently. Okay, so now going on to the demo, I essentially created a very simple data set of 18 observations over here, and this is the observations that we'll be dealing with this particular data frame. I might be adding additional observations to this particular data set if a specific observation example comes to mind, but this is the data set that I will be working with. So the data that we are working with here, we're going to have 18 observations or so, and this is what it sort of looks like. We have a new line character here. We have some specific dates that we can definitely data munge and get to our liking, and we can look at various functions to see what their applicability is when we are working with regex functions. So let's start with the most basic one we have. Let's say that we want to find a any specific character. In this case, it'll just be the letter A. If the letter A exists within the specific data set, then return that using the subset function, where I'm passing in a data function and looking at it at this specific column. So over here, we notice that only one of the observations are not included, and that's observation 1. And observation 1 is the following: hello YouTube. So we know that A does not exist in hello YouTube, so that's why that specific observation was not included. So this is returning those specific characters, if it's true or not, and it returns that specific observation. So we could do the exact same thing for AA. Just return any observation that has 2 letters that are adjacent to each other, and then we can use the the plus operator to find whether or not if there's many A's that are included, and then there's a character that follows after that consecutive one or more characters, then we would want to run that, and we get AAAB. So the A plus, this includes one or more consecutive A's, and it looks for this specific value, in this case the letter B, to be appended at the very end. Okay, now let's print out the data over here, and now let's look at the character groupings that we have over here. So if we were to run this is specifically looking for whether or not this specific character right prior before the letter U exists, then print out those observations. And of course we don't have this. So in all practicality, we would typically have ranges that follow here. So let's say we have a range of A through D, meaning we want the letters A, B, C, or D to exist within that particular line. And if we run that, we can look at whether or not that particular expression actually exists. So right before U, we have it over here. We have the letter B. We also have the letter B over here for but. And right here, nope, that did not match. We need A, B, or C. That fault right here. We have another but over there. So that is, in all intents and purposes, how you would use the character groupings in order to find specific values that exist within here. And more common than not, we would typically see this specific range of functions A through Z and capital A, capital Z, and let's just put like TU for instance over here. And so this is returning all available characters, both lowercase and uppercase, if they exist, and the letters TU must follow after. So in this case, we have a lowercase u over here, which matches this specific value, and anything that falls under here. This would be the exact same thing we have A through Z, because this is the letter U. And if we even go a step further and put this as just U, we're still going to have the exact same thing. So that range just symbolizes a larger range in order to identify what type of pattern that you might want in your specific regex expression. And of course, you can have the exact same thing for, let's just say we have a grepl function over here, and we are passing in the letter T, for instance, and you're passing that into text. We have this, and then let's say that we want to have numbers, a range of numbers that are following the letter T. And then you just typically do this. You would have T, and then you can have your brackets, and let's have all the digits that are associated with that. And this is what that looks like right here. So we can only extract this specific observation because we have the letter T, which is at the bot, and we have the numbers that follow, which is a 2. So you can definitely use this range for a variety of matters, but this is probably the most popular one when we are looking for all numbers that exist in this specific pattern. And as I mentioned earlier, let's look at anchors. So there are 2 anchors. We have a caret and we have a $sign. So Very simple. All we do is have a caret function over here, and let's just go get all the data represented with that specific caret function. So we have h, 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 and h because it is at the very beginning. And if we want at the very end, let's when we're actually working the dollar sign for the very end functions, we want this to be at the end. And then let's get all the digits that are associated with this anchor. And voila, we have this 1, 3, zeros, all these numbers associated with that particular anchor, and that is what that dollar sign represents. Okay, now let's use special characters. These are probably the most popular terms to use because they are so frequent in what we do and are trying to find. And in order to use special characters, we have to use the double slash terms instead of a single backslash slash term. And let's start off with the period, so we can find any periods that exist within the particular data frame. So finding periods within observations, and let's run that. And we have period, and we have this question mark, but no, it's over here. That's another period. So that is how you find periods. However, using this more extensively, let's try to find any digits that might exist within the text. And these represents all the observations that consist of digits. And then of course we can use the other special character, very popular one, just the special character notation of a new line. And this is the new line observation we have here. And that new line observation looks something like, where is it? I just pressed enter right here. This is a new line function because there's no separation. I just press enter and just made a new line. That is what the \n represents there. We can also work with the word function. If there's any words that exist within the observations, then return that. And of course, we all have words that exist here. If we had a null character, actually, let's have a null or a nothing that exists right here. Let's run that again. The data we have here, we have empty. And then if we run this again, we're not going to have any characters. So this can remove any blank characters if you want to replace that specific function. Okay, so let's say that we want to subset the data and we want to limit the number of characters that exist. So let's have like a minimum of 8 characters that must exist within that specific string. And you don't necessarily even need to end it off because there'll just be a minimum of 8 and just get whatever other characters. So there's no other range here. So we have at least 8 characters within each of these lines over here. So let's try to bring it down a little bit, and a minimum of 12 maybe. Okay, so the max number of letters we have in a given sentence is 11, and these have the exact same number of digits here, but this is supposed to follow that specific range. So if we had another observation that followed and we have 12 of these digits, so say right here we have 10 of these digits, and when we can just incorporate another one, so that would be 11, 12, 13. Let's run that, and we have a text, and let's run this again. We have that number, but let's put this up to 11 and then no more than 13. Have that as 12 over here. 12 to 13. You can have that number of observations here, and that's a minimum of 12, maximum of 13. So I hope you understand that basic idea of the ranges of the minimum and maximum number of characters that exist in that particular string. Okay, so now that we have a basic understanding of how to utilize regex functions, we can go ahead and look at grouping and how to replace specific observations that follow a specific pattern with other observational, inferences here. And so I'm going to be using the handy lapply function. Pass the function onto this data set where the function is defined as function x. And then of course we're going to be passing in a g sub over here. That's supposed to be a u. And then we are going to be passing in a specific regex expression onto the x. So we're passing in the data and we're passing in whatever pattern that we might see. We replace that with a given, we're going to replace that with something else over here, and this is going to be the input. So this is what the basic format is going to look like. So what happens if we want to replace the very specific right here, like a very specific date? First, let's go ahead and find that date. So the way to do this, we have to find the number of digits that exist, no more than 4. limiting of 4. And then let's go ahead and start grouping this as I mentioned earlier. So this would just be one group of the first 4 digits. Let's get that next group over here, which would just be characters in this case. And so this would just be, let's get the range, all lowercase and all uppercase over here. And let's limit that to 3 as well over here because we have March, 3 characters there. And then let's create another group over here. And then we can extract this, get the number of digits, and this would just be 2. So let's see if we replace that. And voila, we don't have anything on those dates. I have seen dates like that. Let's see if we replace this with like date replaced. Run that, and we have date replaced. So as you can see here, we are iterating through all the number of observations that we have going on throughout our entire data set, and we're looking for this specific pattern in each of those rows, and we want to replace that specific pattern with date replace in this case within that specific parameter x that we are passing in with the data set, and we have that here. So what happens if we want to rearrange these specific values? So let's go ahead and just copy this like 3 times. And then the way to rearrange this, since we already grouped our given observations, we can have 1, and then we'll just put a dash here, and then 2, and then another dash, and 3 over here. So this is what that looks like. So since we have our very first group, the very first 4 characters, in this case the very first 4 digits over here are matching with that, that is one group, so on and so forth for the March and the 23 numbers over here. And this is the 1, 2, and 3. So we can easily rearrange that as well. Let's say we want the very first group to be, well, the month to be a part of the first, and then let's say we want the in this case the year, and then the day for whatever reason that may look like. We have March 2002 23, and of course you can go ahead and do 3 and then 2 and then 1, and that looks like 23 March of 2002. So very, very nifty. You can do many things with just like rearranging specific values to get a very specific output that you are looking for. Now, of course, there are libraries that will aid us in our process to essentially use very specific regex expressions or really neat functions that we can use in order to find patterns or replace those specific patterns. One of these functions is like a string replace all, and this is part of the string R package, which is a dependency for tidyverse. And then let's say we want to remove all these special characters that we have here. So let me just type in all these unique characters that we have going on here. We don't need numbers as well, just special characters in general. Let's say hello and then underscore world. Okay, so this is the specific observation that we want to replace all of these special characters with. And so the way to do this is to either use a typical regex expression, like we have, like, you know, let's say we want to find a range, and then we want to negate anything that might exist that is not a specific character, like not a alphabetical character. So let's say a underscore Z, and then let's not include the commas as well, and then let's replace that with nothing. And what does that look like? Okay, so actually let's remove the comma. Yeah, so this is what that looks like. We removed all the special characters from our original special character observation, if you want to call it that. So a really neat way, as I was mentioning earlier, is to use these packages to our advantages. And one way to do that is to use a specific function, and this is related to the base R function, and this is just calling in remove all the punctuations that exist. And these are all the punctuations that have been removed. We would probably have to do some additional work, but all of these specific functions that exist here reside in the base R packages. And this is what I mean by the base R regex expressions. It's already built in R. However, as we scroll down, we can see that there are many sorts of functions that we can include into our overall regex expression pattern recognition in order to either remove them, replace them, identify them, you name them, and they have all these functions that we can use that are already built in and are ready for you to use. And wow, yeah, that pretty much covers all you really need to know about regex expressions. Of course, with all this little foundations of knowledge, you can combine them all into this one gigantic pool of knowledge in order to apply this to more intense, more expressive regex expressions that exist out there that just look really hard on the eyes. However, you just need to break it into small components, break out what each individual component is doing from left to right, and you can easily decipher what that regex expression is doing. So if you made it this far, make sure you leave a like, hit that subscribe button while you're at it, and I am so grateful that you made it to the end of this video, and I hope to see you in my next video. Thank you so much for watching.